Hi, Chem Peeps. Let's talk about the solubility rules and determining whether a compound is going to be soluble or insoluble. First of all, the solubility rules I listed here are the ones I've generally used over time. Some are a little bit different, but they're generally similar. So please work with the one that your teacher or your book is using. But for this purpose, we'll use this one. So these list the different types of solubilities and insolubilities in compounds. I tell my students to first look at the ending or the cation or the anion or polyatomic ion it ends with. Each rule starts out by telling you what the rule is for that type of compound based on what it ends with. So you can see rule 1 are nitrates, rule 2 is chlorides, 3 is sulfates, 4 is just talking about family 1, the alkali metals. Then we have oxides and hydroxides, and then sulfides, and then phosphates. Now, a couple things I want to point out. Rule 2 is about chlorides, but there's no rule on here for compounds that end in bromide and iodide. Well, they're in the same family, so they're going to have the same rule as the chlorides in general. Notice rule 4. Rule 4 is talking about family 1 and ammonium compounds. They're always soluble. The other always are nitrates and acetates. So those are things to kind of take note of when you're doing these. So let's look at the first example. We have calcium bromide. Bromide would fall under rule 2 with the chlorides, and potassium is not an exception. It lists silver, mercury, lead as exceptions. So this is going to be aqueous, or what we would say dissolved in water or soluble. The second one, carbonate. Carbonate would be rule number 7, and they are insoluble unless it begins with an alkali or a ammonium polyatomic ion. It does not. It starts with lead, so it is insoluble, does not dissolve. We put solid. The next one is boron sulfite. Now, I don't have a rule here for sulfite, but I'm going to guess that it's going to fall very closely to the sulfates. And they're soluble except for barium, strontium, and lead, calcium, and silver. This is not an exception. I'm going to say aqueous. Zinc hydroxide will take us to rule 5. They're insoluble unless we're dealing with alkaline or alkaline earth. Well, zinc is a transition, therefore it's insoluble, and it is in the solid phase. Sodium acetate, that's an always rule. Rule number 1, they're always soluble. So we're going to say aqueous. Silver iodide, that's going to fall under the same rule as chlorides, rule 2. And silver is an exception. It is insoluble, so we're going to say solid. The third one, or cadmium 2 sulfide. Cadmium 2 sulfide is a transition metal, and sulfides in general, rule 6, tells us that they're insoluble unless we're dealing with an alkali metal, alkaline earth metal, or ammonium. Cadmium is a transition, so it's solid or insoluble. Zinc carbonate, that is going to be rule 7. They're insoluble unless we have an alkali or ammonium, and zinc is a transition, so it's insoluble, solid. Letter I, silver acetate, that's rule 1. That's an always rule. Always double clicking there. Aqueous or soluble. Copper 2 sulfide, rule 6, is insoluble unless we have an alkali, alkaline earth, or ammonium. Well, copper is a transition, so it is not an exception. It is insoluble. Magnesium phosphate, rule 7, is insoluble unless we have alkali and ammoniums. Magnesium is an alkaline earth, so it would not be an exception. It is solid. Hydroxide, potassium hydroxide would be rule 5. They're insoluble unless we have alkali or alkaline earth. Potassium is alkali, so this is an exception. It is aqueous. Nickel chloride. Chlorides are soluble unless we have silver, mercury, or lead. Nickel is none of those, so this is going to be aqueous. Ammonium hydroxide. Now, when we look at rule 5 for hydroxides, it says it's insoluble except for alkali and certain alkaline earth. But look at rule number 4. All alkali and ammoniums are soluble. So this is going to be aqueous. That one was a little tricky. Sulfate, mercury sulfate, if we look at rule number 3, they're soluble. And mercury is not listed there as an exception. I could see that being different maybe on another chart, maybe tweaked a little bit, but this is going to be aqueous in this example. And lead iodide. Iodide's not on the list, but chlorides are, and they're in the same family, so they're going to have the same behavior. It is soluble unless it's an exception, and indeed it is an exception. So this is insoluble solid. I hope this helps. Find me on YouTube and YouTube and TikTok at Kim's Chem Chats. Talk to you later.